It'll still be there Monday morning. All right, so we're doing properties of logarithms. Before we jump into properties of logarithms, I want to review properties of exponents. Because remember, logs are the inverse of exponential functions. So you need to know the properties of exponents. So back in the day, when we were reviewing exponent properties, we had a chart. Redrawing this chart, doesn't hurt to have it on there. So when we talk about operations on like bases, we're talking about things like doing power, or multiplying, or addition, subtraction, divide, and roots. Now those are powers on like bases. For example, if we had something like x squared multiplied by x to the fifth, these are like bases and we are multiplying. How do we simplify this? How do we multiply this together? We write x to the what? How do you get 7? You add your exponents. So when we are multiplying operations on like bases, when we are multiplying, we do what's underneath to the exponents. So if we're doing a power, if we're doing something like x to the second to the fourth, what would we do to the exponents? If we're doing a power, we would do what to the exponents? We would multiply them. It's what's underneath that you would do to the exponents. So we have done that chart when we were first starting to talk about exponentials. We did that chart. Now, since logarithms are related, they're inverses of exponents, they have similar rules. Where you won't do the same rule. Well, you'll see in a second. I mean, I can't write and think at the same time. Hold on. This is a operation on exponents. So you're going to see how logarithms are different. So we have 3 core concepts, 3 properties of logarithms that we're going to look at today. And I'm going to give you actual number examples for each of these. So the first one is called the products property. And we start with log some base b of mn. Mn would be 2 numbers multiplied together. So I'm going to give you like a real number example. How about log base 6 of I'm thinking. I'll just do 10. There we go. So if I have log base 6 of 10, 10 is 2 numbers multiplied together. Do you know what 2 numbers multiplied together would be 10? There's more than one answer, but 5 and 2 sounds good. Right? 10 is 5 times 2. So what this says is, if I have 2 numbers that multiply, what I can do is I can actually expand this out to be separate logarithms of each of those factors of 10. So I can take this, and instead of multiplying, we're going to separate the logarithms, and we're going to add them. So that is using the product property. It also goes backwards. If I have 2 separated logarithms with an addition sign, I can condense it back by multiplying the 5 and 2 and writing just 1 logarithm of 10. So we go either way. Just like when you multiply like bases, you add the exponents. This is the same way if I'm multiplying, I have to add the logarithm. The next is the quotient property. So this says if I have log base b of 2 numbers being divided, I'm going to separate this into 2 separate logarithms, but subtract them. So I will have something like log base let me do this the other way. Log base of, I don't know, 7 of 20 minus log base 7 of 2. If I have something like this, so I'm just going backwards on this one. If I have that. Using this property, I can condense this down to one single logarithm, and that's still going to have the base 7 because they're the same. What will I do with the 20 and the 2? I will divide them. I will do 20 over 2. And I might want to do that because 20 over 2 does reduce to 1. So that would be, we would be able to do that using our properties we're learning right now. And then the power property says that if I have log base b, and then of that log, I have m to an n. I have a power in there. I can take that power and I can move it to the front of the log and multiply it by that log. So if I have log base 3, 27. Log base 3 of 27. Do I currently have an exponent anywhere? Do I have a power right here? Can I rewrite 27 as a power? What is 27? Log base 3 of 3 to the third. So now I have this power. And using this property, I can take this power and I can move it to the front and multiply it by that log that we have left over there. So I can rewrite this as 3 multiplied by log base 3 of 30. And why would I want to do that? Do you guys know anything about log base 3 of 3 that's about to be on your quiz tomorrow? Their inverses, what happens to log base 3 of 3? They cancel each other out, and look, we just get 3 here. Something else that's going to be on your quiz tomorrow might be just evaluating this. It was in your review. This is not using the quotient property. It's just evaluating this where you say, 3 to what power is 27? What is the answer? 3 to what power is 27? That answer, right. That's a faster way of doing it, but I'm showing you a new property. Okay, so let's do some of these together. In the directions, we have log base 2 of 3 given to you as a decimal. Because we don't know how to find that answer other than, okay, they gave it to us. So the answer of log base 2 of 3 is 1.585. The answer of log base 2 of 7 is 2.807. We have to find the log base 2 of 3/7 using this information. So using this information right here, and using my properties I just went over. A little closer. 3 over 7 is division. And up here we have a 3, and we have a 7. What property allows me to take division and separate out that 3 and that 7? The quotient property. So I'm going to rewrite it as separate logarithms and have log base 2 of 3 minus log base 2 of 7. That's using the quotient property. And I separated those because there's an answer for log base 2 of 3. What's log base 2 of 3? Log base 2 of 7. You guys know how to do this already because I'm not sure why we're talking during this part. This should be really easy. How do I find the answer of 1.585 minus 2.807? Is it going to be negative or positive? Negative.
That's good.
Okay, next is log base 2 of 21. I'm not given the answer to log base 2 of 21, so I have to come up with 21 using the information I was given. How can I make 21 from what's given? How can I make 21 from 3 and 7? And multiply them together. So this would be the same thing as log base 2 of 3 times 7. If we're multiplying using our product property, it says you're going to expand it with addition. Log base 2 of 3 plus log base 2 of 7. So that's 1.585 adding 2.807. C says log base 2 of 49. You have to be able to get 49 from the information given. How do I get 49 from the information given? I'm given log base 2 of 3 and log base 2 of 7. 7 squared? Or 7 times 7 is also okay, but I'm going to think about this being log base 2 of 7 squared. So now I'm going to use my exponent rule, which is called the power property. It says if I've got an exponent on this number, I can pull it to the front and multiply it. So I will have 2 multiplied by log base 2 of 7. So that's 2 multiplied by 2.807. Or 5.614. Question D says log base 2 of 1/3. So using log base 2 of 3 or using log base 2 of 7, I have to be able to get 1/3. How do I make that 1/3? Carly, how do you make 3 into 1/3? It's going to be in your quiz tomorrow. In this chapter 5. That's that. Yeah, 3 to the negative 1. That's 1/3. So I'm going to replace log base 2 of 1/3 as 3 to the negative 1. So remember, the negative exponent says reciprocate, so these are equivalent. So if I have 3 to the negative 1, where's that negative 1 going to go? Goes to the front and we multiply it. So we have negative 1 multiplied by 1.585, or negative 1.585. Now there are 4 you try them questions. 4 of them are you try. So take a moment, you try the next 4. I expect to see this first step where you expanded it using your properties, not just an answer. as you get done with these, I put the answers up. You can check your answers with mine. Make sure you get them correctly. And then if you're ready to go on, turn a page so I know I'm reading them. Okay, if you're ready to go on, switch the page so I know who's ready to go on. If you're typing on your phone, should not be. I don't care. Unless there's an emergency. Okay, so the next section, we're not going to do the entire packet, by the way. We're not doing the very last page. We're just doing this page. The last section that we're doing today is expanding and condensing. It's the exact same thing we were just doing, only there's going to be more than one step. And you're not going to necessarily be able to find one answer. You're just rewriting this a different way. So this, example 2 says expand ln 5x to the 7th divided by y. So you have to look at 5x to the 7th divided by y. And you have to think about what is being done in what order, using like order of operations. And you have to pull it apart and to expand it using the opposite of order of operations. So here, if I were to do 5x to the 7th over y, if there were actual numbers there, I would do x to the 7th first, then I would multiply by 5, then I would divide it by y. But I have to do that in the opposite order. So what's the last thing I just did? I would divide by y. So I'm going to pull that apart first. So I'm going to expand it, and since it's division, we will rewrite it as subtraction with separate ln's. So we have ln 5x to the 7th minus ln y. So that's the first step. So ln y is just one thing, so I don't have to do anything else over there, but over here there's still multiple operations happening. So I have to expand this out further. So the next thing I want to expand out is just the 5 from the x to the 7th. And those are right now being multiplied. So when I expand them, they become addition with separate ln's. ln 5 plus ln x to the 7th, and then minus ln y. Expand them out. And then the last thing is in the middle term, we have x to the 7th, and that 7 can be put in front of the ln as multiplication. So we have ln 5 plus 7 times ln x minus ln y. So we're just using those rules to expand out this expression. So that is expanding. Condensing would be the opposite of that. Condensing would be putting it all back together. And when you condense, you get one logarithm when you're done. Just like in the example 2, there was one ln. There was not like ln here, ln there. So here I've got log, log, log. When I'm done, it will only be one time I write log. So for condensing, I'm going to start here in the middle with that 3. And I'm going to move the 3 to the 2 and make it a power. But since I know what 2 to the 3rd is, I'm going to write the answer for 2 to the 3rd. Okay, from here, since I have addition and subtraction left, if it is addition, it gets multiplied. If it's subtraction, it gets divided. So this is addition. So that's multiplication. This is subtraction. That's division. But we condense it down to one logarithm. So I'll just do it one at a time. These two are addition. So we'll write it as log, and then you do 9 times 8, which we can find the answer in a moment. We still have minus log 3. Since log 3 is being subtracted, we write it as log, what's 9 times 8? 72 over 3. So we do not write log for both parts. We just write 72 over 3 with the one log. And then that does simplify to log 24. So that is the condense. The next one is expansion, and see if you can do number 5, but you'll probably make a mistake on 6, so I'm going to do 6 with you. So do number 5, try number 5, move forward. My word for this. You want to think word operations, but like the opposite of it when you expand it out. Okay, so number 5. When you look at log base 6 of 3x to the 4th, what's the first thing we have to undo? What's the last thing done, order of operations? So I have 3x to the 4th. Do I do multiplication, or do I do exponents first? Exponents. So then what do I have to expand out first? Multiplication. So I'm going to expand out the 3 with the times x to the 4th. So I have log base 6, 3, plus log base 6, x to the 4th. Then from there, we take that 4, we move it to the front of that log, and you're done. So number 6 is a little bit trickier. Number 6, when you have ln 5 divided by 12x, what do you do first? If you have 5 divided by 12x, what do you do first? Here, I'll put it with a real number. If I have 5 divided by 12 times 60, what do I do first? Don't I do 12 times 60 first? It's a little bit more challenging to do in this situation. So this is how I'm going to approach this one. I'm going to undo the division. but I'm also going to pay attention that ln 12x was actually supposed to happen first. So to show that, I put it in parentheses, because parentheses means do this first. So now I'm going to expand out that ln 12x, and that's multiplied. So I'm going to expand that part by writing ln 12 addition ln x. And then I'm going to get rid of my parentheses. How am I going to get rid of my parentheses? You distribute. That's right. Thanks for playing along. So we have ln 5 minus ln 12 minus ln x. Now I can go back and look at my original and tell you this is why it works. Anything that has a minus is going to be on the bottom. So you look at the very original question, since it's 5 and it's divided by 12 and divided by x, both of those get the minus, because they're both being divided. That'll be the trickiest thing to have. All right, and then the last ones are condensing. So when we condense, we look and we see this is subtraction, so that means do what? 1 logarithm and what? Subtraction means divide. So we do x over 9. And there's nothing else to do. Number 8, I've got a cube that I'm going to move up and make that 3 cubed, which is 27. And then anything that's addition ends up on top. Anything that's subtraction ends up on the bottom. So I will have ln, and on top I'll have 4 times 27, and on the bottom I will have 12. Anything that's addition goes on top, anything that's subtraction goes on the bottom. Or we could do it one step at a time and get that the same answer. So I've got 4 times 27 divided by 12, 9. ln 9 is my answer. So the assignment that I'm going to put up is not due until Monday. It's not due until Monday. So after your quiz tomorrow, you'll pull your notes back out and work on it. Okay? And then I'm going to stop the video and then we can go over the review for our quiz.